Right, now we are going to talk about comparing numbers. So we want to put a less than or equal to or greater than sign, fill in the blanks between the numbers with these three signs: less than, equal to, or greater than. Okay, so before we begin, it's maybe useful to revise some of these concepts. So the way to think about when we are comparing numbers is I always try to picture the real number line in my mind. There is a 0, there is positive numbers, and there is negative numbers. And so the smaller numbers are on the left and the larger numbers are on the right. So the further right you move on the real number line, you will see more and more positive or bigger and bigger numbers, and the numbers on the left are negative numbers, or the numbers that are smaller. 0 is, you can think of it as the center. It's not really the center. There is no center to the real line, but you can think of it as a starting point. To its right are the positive numbers, to its left are the negative numbers, and numbers on the left are smaller than the numbers on the right. So the way I like to remember this is that if two numbers are present on the real number line, one is on the left of the other, then this relation, this less than relation, is the relation that defines which number is on the left and which number is on the right. So suppose I am given two numbers here, 7 and 8. So these numbers are placed, let's say 7 is here and there is 8 here. They are placed in their natural order on the real number line. So the relation between them is this less than relation. So that's something useful to remember, that the numbers on the real number line are arranged according to their less than relationship. Okay. So before we go into the actual details of these examples here, there are 5 or 6 examples here. To the rules that we will be using is as follows. So first is so negative numbers are less than 0 are less than positive numbers. So if you are given an example here, let's say in the sixth case, or rather, which case is this? When we are second and third case, maybe that's just easier to knock it off. So I'm solving example number 2 here. So 0 and 8. So 0 is less than positive number, so this is less than. The third example is 0 and minus 8. So 0 is greater than minus 8 because 0 is greater than all negative numbers. So these two are easily solvable using our first rule. Let's just call it rules. Second is, so if you have, let's consider the case when both numbers are positive. We'll also consider the symmetric case when both numbers are negative later, but let's consider the case when both numbers are positive. Then the number with more digits is larger. So if the number has unequal number of digits, so suppose one number is 2-digit number and the other number is a 3-digit number, then the 3-digit number is larger. So that can help us with example number 1 here, which is 56 and 653. So 56 here is a 2-digit number and 653 is a 3-digit number. So the rule says that the number with more digits is larger. So this 653 has 3 digits. So this is the relationship. 56 is smaller than 653. Actually, the fourth example is also a good illustration of this fact. That let me clarify this rule a little, excluding leading zeros. So in the example here, let's do this example carefully. 873 with a leading 0 versus 1000. So 873, 873, I'll write it that way, versus 1000. If there was no leading 0, then this is a 3-digit number, and these 1000, these are not leading zeros, these are trailing zeros. They are not part of the first or the leading part of the number. So these are not leading zeros and I cannot ignore them. This is a 4-digit number. This 873, the way it is written, looks like a 4-digit number, but I have to exclude leading zeros. These are of no use and no value, so remove them. This is a 3-digit number. 1000 is a 4-digit number, so this sign is less than. So it is like this. if there are unequal number of numbers, so number with the more number of digits is larger. If there are equal number of numbers, then compare from left to right. I'll show you how to do that. Compare digits from left to right if equal number of digits. So let's see what I mean by that. The 678 versus 874 is a good example here. So 678 versus 874. Now let's see if any of the first two rules applies. Negative numbers are less than 0, less than positive numbers. That is true, but it's not applicable here because both numbers are positive. So we go to the second rule. Both numbers are positive. The number with more digits is larger, but these are both 3-digit numbers. This is a 3-digit number, and this is also a 3-digit number. So it's not possible to directly apply this rule and get which one is larger and which one is smaller. So then we go to the next part of the rule, which is compare digits from left to right if equal number of digits. So left to right is from the left of the number, which is the first number here is 6 and second number here is 8, or rather the first number in the second number is 8. So 6 is less than 8, so the entire number on the left is less than the entire number on the right. So we have 678, which is less than 874. Let's take a similar example here. Suppose the numbers were slightly different, 678 versus let's say 675. Now again, these are both positive numbers. These are both 3-digit numbers here. So we cannot use the first two rules. So we have to start comparing the numbers from the left digit. So this 6 is equal to this 6. So we have to go to the next digit now. This 7 is equal to this 7. So we cannot really tell yet. So next we have to compare this 8 versus this 5. Now 8 is greater than 5. So the number on the left, the entire number is greater than the number on the right. So that's how we proceed. That we start comparing digits one by one from left to right. And the moment the numbers are unequal, one of them is smaller and the other one is larger, that's it. We stop comparison, and the side with the bigger number is the bigger number, is the winner. So 678 will be greater than 675 using this logic. You have to compare digit by digit. And let's talk the sixth example for completeness here, which is minus 54 and minus 70. So the rule here is if the numbers are both negative numbers, then think of them as both being positive. Apply our usual rules here, rules for positive numbers. These are the rules for positive numbers, or you can think of the second rule is for positive number. And if the negative numbers are involved, then treat them as positive numbers, both of them as positive numbers. Compare them using our usual rule. Compare the number of digits. If the digits are equal, compare from left to right and so on. And then you finally get a result that in this case will be 54 is less than 70. Let's do this properly. So our numbers are minus 54 versus minus 70. So we treat them as positive numbers, 54 versus 70. They are both 2-digit numbers. So let's start comparing from the left. This is 5 versus this is 7. 7 is bigger than 5. So 54 is less than 70. So the rule for negative numbers is whatever result you get for the positive numbers, reverse that result. So minus 54 is greater than minus 70. If the positive version of these numbers is holding a certain order, then the negative numbers will hold the opposite order. So that's the rule. So these are the rules that we can use for comparing not just 2 and 3-digit number, but even bigger numbers, maybe 10-digit or 20-digit numbers. Just to recap, so negative numbers less than 0, less than positive numbers. So if you are comparing a negative number with a positive number or 0, it will always be smaller. Then the important case here is both numbers being positive. If both numbers are positive, then you first remove the leading zeros and see how many digits each number has. If there are unequal number of digits, then that's it. You have a clear winner. The number with the more number of digits is bigger. If they have equal number of digits, then you have to proceed comparing one number at a time from left to right. And the moment you get a larger number, that's it. That number is the bigger number. And if you are comparing negative numbers, two negative numbers that is, then treat them as positive. Use the rules that we discussed And if the if the one of the numbers is, I mean, the number positive version of it is larger than the other one, then the negative version of that number will be the smaller one. So you have to invert that result if it is a negative number. So that's it. That's how we compare numbers with that's how we compare numbers with positive, negative, zero, or unequal number of digits, or leading zeros, or whatever else. All right.